Hey everyone, welcome to another workshop that we are hosting on Metis. This time we are going to be talking about a very exciting topic called Oracle Extractable Value. We have here with us Billy Jitsu, who is the DevRel lead from API3, and it's going to be an exciting opportunity for you guys that are listening here to learn something completely new, something I would say is at the frontier of the kind of interesting things that you can do in blockchain and Web3 in general. And yeah, my name, for those who don't know, is Victor Munoz. I'm a developer advocate at Metis L2. So Metis is a scalable solution that offers fast transactions that are very cheap as well, and we are very happy to have integrated, like rather than integrated, upgraded our network with a decentralized sequencer network. We are going to be talking about this soon in an interesting podcast episode, but right now I want us to focus on this very, very interesting topic that we have today. So how are you doing today, Billy Jitsu?
I'm doing okay. Doing okay. I was trying to retweet the live stream right now as we go, but I'm gonna find it. But
Yes,
yes,
something that I was kind of wondering if we should try in the future to do this directly on X since we have a lot of people there, but
yeah,
that's something that we can discuss later. But it's a good observation.
yes, yeah, definitely. Yeah. But yeah, that's maybe for workshop 3. But yeah, I'm Billy Jitsu on X. Again, developer relations for API3. So let me, if you saw the first workshop, you saw how we did price oracles. We are a price feed oracle solution infrastructure across multiple chains. We showed you how to get a price feed to a smart contract and use adapters. But let me take you through the workshop for today for Oracle Extractable Value. And today, ask a lot of questions, right? Like this is a brand new concept that a lot of people are still learning about. In short, it's basically MEV on training wheels for layer twos. But let's talk about API3. So API3 has a bunch of services. We have Chain API for the ability to bring any off-chain REST API and bring that data on-chain. So like if we had a race and we were hosting it on our own API, we could create, a smart contract platform for maybe some betting and then settle everything on chain once we pull that data on chain. We also have QRNG, which is a random number generator. We all know that EVMs are deterministic, right? So in order to have true random numbers, you have to generate that randomness off chain and then bring that data on chain. So this is what our random number system. Again, there's no token required to do it, just requires native gas of the layer 2. What we did last workshop was our DAPIs, which are basically price feeds that we push on chain, right? So we're constantly pushing all the price feeds for like wrap BTC, ETH, Metis. All that data is being pushed on chain to be used for DeFi oracles systems like borrow lending platforms, perpetuals, etc. And then today's workshop is the OEV network, Oracle Extractable Value, which we'll talk in detail about that. But in short, it allows the users to auction or bid on the price Oracle update. And I'll explain that in just a little bit. I am your development support team. So, again, I'm Billy, developer advocate. If you want to follow me on the socials, sometimes I post serious stuff and technical stuff. Sometimes I post non-serious stuff. So, act accordingly on that. So first workshop, just a quick breakdown for those that missed it. You can always go back to the Metis YouTube and check out the fundamentals of API3, where we just get a basic price feed into a smart contract. Use adapters if you have something for another Oracle code and you don't want to refactor your code, like it's already been audited and you want to reuse it. Definitely check out that first workshop. Today's workshop is going to be about Oracle Extractable Value. You'll see the logo, OEV Network. You're going to understand how push and pull oracles work, introduction to the network, and then learn how to update a price feed by bidding on the OEV network and then actually performing the update. Third workshop, because this is a full series, we want to teach you how to become a searcher, is going to be learning how to deploy Aave and how to do liquidations on a borrow lending. So you're going to learn how to deploy a borrow lending platform with the CLI tool built by the API3 team. Shout out to Vanch and team. And then we're going to learn about liquidating positions, right? When you borrow or when you deposit and borrow a position, what your health factor is, how to calculate liquidation positions, how to repay back the loan, how to do a liquidation. So that's probably going to be like a 2-part series of learning how DeFi works, deploying it, and then a second part is actually doing the liquidations and paying back the loan. Then the fourth workshop, right, as you're becoming a searcher, now you're aware of how to do liquidations. You find a good opportunity somewhere in, on Metis, there is a great borrow lending, position that you want to liquidate. But it's $1 million. Who has $1 million laying down in their wallet? Well, there's flash loans, right, where you can borrow temporarily on the same block, create the opportunity with OEV, pay back the loan, pay it back the loan, and then keep the profit, right? And that's kind of like the two potential of OEV in a total. So like it's a 4 workshop series on different focusing, not just about API3, but just how to be a better, searcher on L2. So today, updated price feed using the OEV network. That's pretty much our goal of the day, because it was a lot of concepts to cover. But at the end of the day, we are just bidding to updated price feed before its usual update.
So
So
there's
mhm,
maybe you can explain this now if you are not going to explain it in the future, like explaining like the motivation of why would anybody like would do this. I know this could be a very like maybe obvious question to you, and for
yeah,
many that might be watching, and for some people that are very aware of about how MEV works, and for
right.
those people that are looking for profit opportunities. But I would bet that for other people that are kind of new to Web3 or just new to Web3 development, they don't even know like the why and what's the opportunity.
Right. Right. Definitely. So, borrow lending is just one aspect of MEV, right? So MEV is, you hear all the time like sandwich attacks, or you hear things like arbitrage, right? So like if I can buy, ETH at $2,000 in this one location, and then I could sell it somewhere else for $2,005. That means I make a $5 profit, right? So obviously
Mm,
people want to go that, do that, right? So they want to be first. So they do MEV to be on the first transaction. So they bribe, $5 for one transaction is not a big deal. But if you do that in the millions, it's giving, $5 million, right? Assuming,
yeah.
there's liquidity and whatnot. So in borrow lending platforms, you have something where you can liquidate positions, right? So like if I deposit $10, I can borrow $7. There's $3 in the platform that is there to pay out rewards or and whatnot. So if my asset that they deposited becomes a lower value, like let's say I deposit ETH and then I'm borrowing USDC, right? There's certain rules that say you can only over collaterate your position once it gets to a certain threshold. Like if the value drops of ETH and you still have that $7, well, now that the platform's not healthy because it could go negative. What if the ETH is not worth $7? Now you have no reason to pay it back, right? So like I could walk away with the money scot free. So we have this liquidation penalties where if your value of what you deposited is not enough to cover what you borrowed, someone else can pay back the loan, right? But then they get that reward back in like 5-10%, right? So if I paid back that $7 loan, there's a 5% reward for me to get paid off because they have that extra collateral. So it keeps platforms healthy, it keeps people honest, right? So we want to, jump on those liquidation opportunities. And so that's kind of where the OEV comes down, right? Because when an Oracle has a value, right? Because they've borrowed off that Oracle value of, let's say it was $10, and it hasn't updated yet, but we know the true value of what that oracle is, and it has it, and we'll get into the details of why that works. If it hasn't updated just yet, you can then use OEV, say I would like to update that oracle so then I can run that liquidation first. So it's kind of like a race of opportunity, right? Because if there's a lot of opportunity to be made, everybody wants to be first. And so
Yes.
the reason you want to do OEV is it lets you go first if you win the bid, in a sense. And then the motivation is profit, right? You're making 5 to 10% per liquidation, depending on the size of the liquidation.
Okay,
Yeah.
okay, very interesting. And
Yeah.
obviously there are risks involved, mostly because of the competitive, I guess, environment that you will face.
Well, we'll discuss that in just a little bit, but it's
Okay.
not really too bad, especially like if you're doing a flash loan and everything. Like things don't work out unless it ends up as a net positive. So it usually works out pretty well for the searcher as long as they are not wasting. MEV on layer one, you could get wrecked, and we'll talk about that in a little bit. But with OEV, I call it MEV on training wheels because there's a lot of points that kind of like guide you along. So it's harder
Mm,
to mess up on there. So yeah,
interesting.
yeah, it kind of continuing on like workshop breakdowns, like the key learning points is like where is the value going right now, right? Because when platforms like dApps, like Aave or any borrow lending dApp, right, they have to pay out this 5% reward every time there's a liquidation. that value is being lost or leaked from the DApp, right? Because in order to stay healthy, they have to pay this fee out. So they're losing value every time there's like, liquidations happening, and when there's volatility on the network, right? Like a week and a half ago, ETH dropped 10%. So, there was a lot of liquidations. So there was a lot of penalties paid out, right? So we'll
Mm,
go through the flow of the current meta of what's happening right now. And then obviously how to use the OEV network, right? We're going to create a bid on the OEV network to be part of the auction. And then we're going to actually execute an update of price with something called multi-call. We're going to go over multi-call as well. So what is
okay.
OEV, right? How do oracles work, right? So like when you go to a centralized exchange, like let's say Coinbase, Binance, or anything, you're looking at the chart every second. It's moving up and down, right? By pennies or a dollar or anything like that. It's every second on the second. There's price volatility. When we try to do this on chain, right? Every time we make a change or do a transaction, it costs gas. So like if we were to do this every second on the second, API3 would be out of business in about 2 weeks because we'd run out of funds to pay for the gas for any update, right? Basically, if it changes a penny, it's going to cost a transaction. If it changes a dollar, it changes cost a transaction. So what the standard is for a push oracle is basically if there's a change in percentage of price, which we call a deviation, whether it's 1% or 0.5%, that's when we push a price change. So like if ETH is $2,000 at a 1% deviation, the next price update that'll show on chain would be either 2020 if ETH is on a rise or 1980 if ETH is on a fall. Does that make sense?
Yes, it
Yeah.
does.
Yeah. So in between, like if it's 2005 or 1999, that will not reflect on chain. You'll see it on CoinGecko or any other kind of like centralized exchange, but it will not reflect on chain because that much price deviation doesn't make much of a difference, right? Right. So Oracle Extractable Value is like, let's say you're a searcher and you found this position somewhere on like Aave, and you say, oh, I could do a liquidation if ETH is $2,005, right? So I'm like, okay. I look at CoinGecko and I see ETH is like $2,010 in value, right? We've been going up since the last update. Theoretically, I should be able to liquidate that position. But because the push Oracle has not updated on chain, it's not going to update till 220. I have to wait to see if ETH ever gets to 220 for the Oracle to update on chain, and then I can run the liquidation. And then everybody that calculated is going to race to try to do that liquidation, right? So OEV allows you to say, hey, I'd like to bid for the update to update it to the latest value. So, my thing is 2005, and I think I said CoinGecko was like 2010, right? So the average cost of what it's going to be updated on the Oracle is going to be 2010. I win that update. Like I do the auction, I win the auction, and I perform the update. Now on chain, it's going to show it's going to be 2010, and then I can run the liquidation. So that's pretty much the whole premise of Oracle Extractable Value, right? We're doing an Oracle update, and then we can perform our activities. So
Got it. Super
what's the
clear.
extractable? Yeah, what's the extractable value part, right? So like just like that scenario, right? We have this liquidable position at 2012, and then ETH is worth $2,000, 1% price Oracle, right? So we know that there was this climb, right? And we see the price off chain, and then we can't liquidate until it updates the Oracle. So then once we do that, we hit it, right? So with MEV, when we do this like on the layer one and MEV, in order to be first, we have to bribe the validator, right? We use like flashbots or something, right? But there's multiple validators saying like, if you'd like to reorder the transaction on this next block, pay me so then I can do it in your favor, right? So basically, if me and you are both going after the same liquidable position, I'm going to say, I'm going to pay 5 ETH to be first. And then all of a sudden you say you're going to pay 6 ETH to be first. You're going to win that one block battle. Your transaction is going to go before mine. And then you get the liquidation. And I miss
Makes
out,
sense.
right? Right. So that's the way it works on, on layer one, because they have different validators that you can bribe. On layer twos, there's only sequencers, right? So theoretically, we
Right.
can't really bribe sequencers in a sense. So it's kind of like depending on the layer two, it's either first in, first out, or some ability to reorder the block transactions. But we theoretically don't have any control. We can't bribe them like validators do. But
Got it.
the where does the value go, right? On the MEV, that value goes to the sequence. I'm sorry, the validators, right? Because I paid that
Yes.
6 ETH or 5 ETH to go to the validator, so that validator takes that profit, and then whatever's left, I keep, from the profits. And so sometimes the profit's kind of low, sometimes the profit's kind of high. It really depends on the liquidation value, right? But I want to get that liquidation. So depending on the price of ETH and the value of ETH and how much I get for liquidation profit, I have to subtract that, right? So like I have to pay 6 ETH, but the reward for the liquidation was like 6.1 ETH. So my net profit is zero point 0.1, right? Because I paid out 6 ETH to go first, and then
Yes,
I
you
did the
have to.
liquidation and I got the reward, right? So that's where we're extracting this value at. We're waiting for this Oracle update to update, or we're forcing the update to happen, and then we're extracting that value. So how OEV helps to aim with this issue is searchers can then bid the update, right? I can bid I would say I like to do this 6 ETH bid update, right? To OEV. If I win the bid update, I get a special signature that says, okay, only you and you can update the Oracle at this time. We have like a few seconds to do so. And so what I do is I grab that signature that I get from the OEV network on Metis, and then I bulk that with a multi-call smart contract to do the update and the liquidation on the same, because we're on a sequencer, right? I have to do 2 different transactions. And if someone sneaks in between it, that they can win the liquidation before me. So we're going to use multi-call, which we will cover in a bit. And so then the price gets updated, and then the liquidation is performed on that same block. And then the value, that bribe value, instead of just going to the validator and then just not seeing it, that value is split. So 90% of that value that I bid goes back to the DApp. So like if Aave was using a wrap BTC Oracle and I did a liquidation on wrap BTC and I bid 6 ETH to go in there, 90% of that 6 ETH goes back to Aave to do whatever they want with it.
So this kind of actually generates a situation in which incentive seems to be more aligned, if I'm correct, right?
Yes, yes. So instead of like leaving the DApp, right? Because the DApp has to pay the 5% to reward to keep the platform, 5 to 10% to keep the platform healthy. Whatever I'm willing to bid to win that auction, 90% of that goes back to the DApp. And so basically, instead of just leaking value over time, 5%, 10%, every time we have fluctuation in price, if they're using the OEV network and they're using API3 oracles, if anybody bids to do that liquidation, they get money back.
And how does that number 90% is fixed? Like who decided on that? Is that something that is dynamic? It can change, or how does that work?
That's how the OEV structure was set up on there.
All
Yeah.
right,
Yeah. So it's currently that theoretically could change if the structure was done, but right now it's currently 90% of that value. 10% goes to a certain percentage, and then some percentage goes to the API3 network to keep it healthy as well. There's kind of a net profit type of thing on there.
got it.
Versus, so basically you use the API3 oracles, and then if someone performs a liquidation, you get value back, right? Versus getting nothing from theoretically any other oracle that you use, because everybody does price feeds, right? But it's one oracle that if you use a price feed, you get money back if you get liquidation. So that's
Got it.
kind of a solution.
100%.
So visually, this is how the MEV flow goes. Kind of I explained it before. So the searcher pays this large gas fee to be first to the validator. So like I paid 1 ETH to the validator. Validator keeps that ETH, right? And then puts the transaction first to perform the liquidation. Borrow lending loses 5% TVL to pay back whatever the liquidation was. And then the unhealthy position gets paid back, and I get that profit. So at the end of the day, the aftermath is the validator keeps the 1 ETH. The searcher gets the liquidation amount minus the 1 ETH that cost them. And the borrow lending DApp gets nothing. Just
Mm,
loses 5% TVL per liquidation, right? With the Oracle extractable flow, I know it looks a little bit crazier, but it's pretty straightforward. So the searcher finds the opportunity, bids on the OEV network to say, hey, I want to bid the 1 ETH, right? And just a quick note, this thing in red is you don't need to have your entire ETH on the OEV network. You only need 10% of your bid value on the OEV network. So you only need point point 0.1 ETH for a 1 ETH bid. If I win the bid on the OEV network, I get a special signature that puts me at like an allow list for my wallet to do the update. I send that transaction to the API3 server that does the price oracles, and then I send the transactions through the sequencer to then update the price feed, which is the token price feed, and then liquidate the position, right? Then I get paid back. And so at the end of the day, the searcher, it's profits minus the bid amount. Like let's say it was 1 ETH. API3 server has the bid amount balance, but the lending dApp loses the 5% TVL, but they get their claim of my bid amount, which is zero 0.9 ETH on this case of the
Mm,
90% return. So they get a little bit back. So that's kind of the change in flow. Just for difference, this is the old flow. This is the new flow. The only difference is you're adding this little side step for the OEV network for the auction. Make
got
sense?
it.
Yeah.
Makes sense.
Okay. I'm also checking the comments here just in case. Okay. So
Yeah, me too.
today,
Me too.
yeah, we are going to learn how to build a searcher bot, like the very, very basics of doing an Oracle, right? So for those that have never done it before, you can use almost any ETH library. There's Ethers.js, VM, Python, Rust. There's a lot of libraries out there that have an Ethers like a JavaScript equivalent or eth.py. And there's a RS one as well. So today, we're just going to use Ethers.js and JavaScript. It's a very simple script to update the Oracle, run the bid, do a deposit, and then update the proxy contract and then pay it back. Uh, in every chain that you do, you need to deploy your own multi-call contract. So if I was doing this on Metis, I have to deploy a multi-call contract on Metis. If I was doing it on mainnet, I would have to deploy my own multi-call contract on mainnet. Why do we use a multi-call? And we're going to get into this just a little bit. We need to be able to bundle our transactions, right? If I send one transaction to update the Oracle and then I send another transaction later to the liquidation, somebody could sneak in their transaction in between both those transactions and then run the liquidation, even though after I paid for the Oracle update, right? The mempool is public, people can see what I'm doing. So we want to make sure that when we send in the price update, we're also doing the liquidation at the same time. And with that, we can use multi-call. And I'll explain multi-call in just a little bit on there.
Okay.
For this script, you don't have to modify anything. We've built it ready to deploy. You just have to deploy it. You could modify it if you want to, but there's no need. It's ready to go out of the box. So just to understand like the liquidation flow of like how a searcher would work, we're going to look at a very top level, and then we're going to go down and down just to get an idea of like what does a searcher do in order to find these opportunities, right? So you as a searcher, anybody watching this as a searcher is like, we got to find these opportunities, right? So we're looking at borrow lending dApps on the chain, right? We're looking at, if Aave is deployed. I mean, I think it is, right? So we're looking at who deposited all the positions, who's borrowing, right? So then we have to calculate price of any liquidations of people that have borrowed assets, especially when things are moving up and down. And so say, oh, okay, I can liquidate this position if ETH hits, $3,000, right? And so I have this list of database on my local machine to let me know, hey, if I see an opportunity, I'm going to place a bid on the auction house contract and say, hey, if ETH hits this price, I'd like to update this Oracle. We win the auction, right? We get that little signature. I combine the price update signature and the liquidation transactions with my multi-call. I send that transaction out. Price feed updates, liquidations occurred on the same call. That's a very high level version of like what a searcher does, right? Find the position, win the bid, bulk it together, run the transaction.
Okay, got it. Super clear. Just one quick question here.
Yeah.
Let's give a sort of high level quick roadmap for someone that is has coding skills and wants to really become a searcher, because I think that there is a work to be done there, right?
Yeah. Yeah. Well, I'm gonna go a little bit lower. This is a super high level on here. Let me go to the next one right here.
All
Boom.
right.
So this is on your local computer flow, right? So
Okay.
we're gonna if I put it all at once, it gets kind of scary. So this is what's happening on your local machine, right? So again, on this layer two, right? We want to gather all the user addresses that have borrowed, right? So we from the very beginning of deployment of this contract for the borrow lending dApp, we want to get all the users that have deposited something and then also that have borrowed, right? So then we have a local database on here of all the addresses that have ever deposited and borrowed, and we want to monitor all the health factors of each one of those users, right? So people are pretty healthy sometimes. So the health factor is for Aave is one. If a health factor is one, they're in danger, they could be liquidated, right? We're going to store those opportunities on a database list on our local machine, right? Whether it's like some kind of SQL database or something, but we have this on our local machine. And now with all our opportunities, we have to calculate the liquidation price of every one of those positions, right? So like if they don't change their positions or repay back the loan, these are the prices that I need ETH to go at, right? So with all this calculations of price, I see one that comes up, as ETH is going up or down, I, send some magic to do the bid of the OEV network. It does its magic. I get that signature. I combine all those winning auctions. Maybe I did one or two or three or four auctions. I combine all those auctions and I bulk it in the multi-call, right? On the layer two, I'm calling that multi-call contract, updating the proxy feed, and then performing that liquidation, right? So here we're getting a little bit more detailed on like what's happening on the local computer. You have to have like a little database. You got to like learn, what positions are available, right? So like you have to do a little bit of like databasing on your back end to have the most up-to-date list, right? You can use resources like the graph or, like doing analytics to help you, and then some local calls to get the most up-to-date. Then
Got it.
the entire flow right here, right? So the green is OEV network, white is local computer, and then it is Metis would be the layer two here, right? So again, same thing. We're gathering the addresses, we're storing them on our machine, we're monitoring all the health factors by calling on the health factors, we're storing those opportunities, we're calculating the liquidation price from all those positions. We see a position that has opportunity, we set up our bid conditions on the OEV network, we place a bid on the auction house contract on the OEV network. We're listening for the bid results. Did we win? Did we not win? We won. We received the winning auction signature. We bulk all our winning details in the auctions and our liquidations for those positions. We call on the multi-call contract on the layer two. We update our proxy price feed. We perform the liquidation. And at the very end of it, we report back that we updated the Oracle. That way, in the OEV network, when you win a bid, you have a duty to perform that update because you have that sole, allow list to be able to do this yourself. And if you don't do it, you're going to get slashed. It keeps you honest, right? Like if you don't do the job that you won, you're going to get slashed from your stake from the auction. So that way it keeps everybody honest. And that way people can't mess up somebody else, if they're trying to win the auction as well.
Mm,
This is the entire flow of the OEV auction, like a searcher. What we're going to do today is basically from the green, set up the bid conditions, and then do this. We're going to do this right here, this section right here. So this is
got
today's
it.
workshop. Yeah.
From setting up a bid.
Yes. Set up the bid conditions. This is all in the script. We're going to place the bid, listen for the bid, and then, do the multi-call, update a feed. We won't perform the liquidation because we have nothing to liquidate on. Again, that's a lot of information to swallow, but we're going to report that we updated the Oracle.
All right.
Yeah. So some details, right? So on the OEV network, you only need 10% of what you're willing to bid on the OEV network. We want you to keep the liquidity of whatever L2 that you're going to go on there. So like, we don't want all liquidity on OEV. We want it on Metis, right? So if you're going to bid up to 10 ETH, the only thing you need on the OEV network is 1 ETH. You can bid you only need to stake 10% of what you're willing to bid on the OEV network that you're going to bid for the L2. You don't pay the fee on the OEV network. So like when you win the bid and you need to pay the fee, you pay that on the layer two that you're actually updating the price feed on. So if I want on Metis, I pay that fee on Metis, right? Again, the fee value gets passed to the API3 server contract, and then the price feed updates the transaction. If you don't pay the fee, you can't update, right? You have to, whatever you bid, you got to pay. And then the DApp, so let's say it was Aave, they can then withdraw that value from the server contract, and then they can use that for whatever they want, right? That's their money to do whatever they choose. So basically it's newfound value or profit for that liquidation that they've never had before. So they can
Mm-hmm.
either, reward the stakers, right, with a better APY, or they can lower the liquidation penalties. They could fund public goods. They could have giveaways,
Whatever
whatever
they want.
whatever they want, right? Like it's new ideas for users. So like that'd be a cool hackathon idea. Like what can you do with your newfound value from OEV network, right? So yeah,
Yes.
a little bit more details. In your bid details of the OEV network, the address of your transaction is part of the winning signature. So what does that mean? It's you can set who's going to update it on the layer two, right? This is part of the allow list, right? With sequencers, again, we can't bribe to be firsts theoretically. So we have to make sure that there's a allow list so that if we're not first or if we're last on the transaction, we make sure that our wallet is the one that actually does the signature, that actually does the update, and then make sure that we perform the liquidation right after. So we basically allow list it. So if someone tries to front run it and sees it on the mempool, it won't work because they're not allow listed, right?
Got it.
There you go. So the multi-call contract, which we'll get into a little bit more details, allows us to combine the transactions into a single call. And so therefore make sure that your price feed goes first and then the liquidation calls. Don't do the liquidation and then the price feed, because the price feed won't be updated and then you can't run the liquidation. So you make sure you have the correct order.
Exactly.
Yeah. And so basically, if you don't call the price feed without a multi-call, like the next transaction can be front ran, right? Like, so I do the price, I win the auction, I do the price feed update, and then Victor says, thanks for the update. I appreciate it. And then they do the liquidation, right? So make sure you bulk it all together. Okay. So you can always check out our Discord community for more questions. We have a channel for OEV. I know it's a lot of information to swallow. And maybe you have to watch the video a few times, but we're going to go through the script really quick. And actually, we're going to have you, Victor, actually go through the playground and then
Awesome.
run through this transaction of everything that we kind of just covered today. So in that aspect, I'm going to kind of like hide my screen and then have you go on there. And then in the comments, I'm going to go ahead and just pop in a few things here. We want
Yeah,
to
for sure.
bridge. So in order to join the OEV network, we're going to have to bridge over. So I'm going to post that over. It comes from mainnet. And then, oh, I guess I can't post this. I'm going to do it to the private chat. And I'm just going to post it
Yes.
to you if you can pass it. You have to
Do that.
bridge your ETH from mainnet to the OEV network. Like I said, it's only 10%. So again, if you're going to do one ETH, you only need 0.1 ETH. For demo purposes, everything's done on mainnet. We don't have a test net yet for the OEV network. So we're going to be doing everything with like real money. So real Metis L2 and everything as the such. And then when you are ready to rock, there is an OEV playground that I've kind of already set you, because bridge takes a little bit of time. I'm going to do this playground once again.
Yes.
This is what Victor's going to be using to basically go through everything we've just done.
Yes. Just 1 second while I'm sharing these links here, because if
Yeah.
I share my screen, then it looks ugly.
Yeah.
So now let me
Of
present and share my screen over here.
course.
Uh, yeah, we're gonna go into the playground mode. Let's do that.
Yes.
So I am on the site playground.api3.org.
Hmm.
Please get the correct link. It is on the comments, so always make sure of that. And I have connected my MetaMask wallet here, uh, and it seems that I have some balance here, right? So just
Yes.
one quick question here, since you helped me out getting this ETH. I was wondering for the people in the audience, what's like the fastest or cheapest or better way that you would advise for people to get their ETH there?
You have to use the bridge.
All
You have to
right,
use it. Yeah, yeah. The reason
no
we
other
haven't
way.
bridged from mainnet is because it takes a few minutes in order to do so, and like we have a lot of stuff to cover. So I just sent you a little bit of ETH in order to get it up and running. But you would use the bridge to basically bring your ETH from mainnet to the OEV network, and then wait 10-15 minutes, and then it shows up on the balance. We just kind of cut that corner of the bridge. But like any other bridge, like if you're bridging a Metis, the same thing, right? It's just you're using the
Yes.
OEV network bridge. So figured I'd,
All
I'd
right.
get you a head started there. And so I just private chat you the amount that we want to deposit. You don't have to use a lot on there, but basically it's a single flow of how the OEV works, right? We're going to deposit it into the auction house. And then if you look at the tab is grayed out, we're going to place a bid, and then we're going to execute that update. And then we're going to
So
report that we did that update. So go ahead and
awesome.
deposit that in there. Yeah. So we're depositing our stake into the auction house, because if you want to run a bid, you have to make sure that you have a little skin in the game. So we have to deposit a little bit of ETH in there.
Yes, I'm paying now the transaction fees, pretty
Yeah.
cheap, 0.8 total.
Yeah.
Uh, so you will see it's going to be done in 1 second here. Let me check out my MetaMask. I don't think you guys can see this. Ah, now you can. Okay, I think the contract interaction was done and it's
Yes.
showing here.
Yes. So now you can see that place bid has just turned on, right? Now you have a little skin in the game, right?
Ooh,
So now we can
ooh.
start placing bids because I have a value in the auction house. So we're going to go over to Metis. We can search it down. You can type in or you scroll down. We available on all different chains.
Yeah, I'm very impressed about this, like
Yeah.
many chains.
And
Now,
so data
please go
feed.
ahead.
Oh, so we want to choose the data feed that we want. Right now we have wrap BTC and I think USDT live on there. So if you just type in wrap BTC or WB on the
Uh,
top, scroll up to the top.
let's scroll up to the top here. Oh, I don't
Nope.
see the
On the
place in
select
which
data
you
feed, yeah,
can.
just click it again. Right there,
Oh,
search.
okay.
There you go.
So what do you want me to type? Sorry.
Wrap BTC or WBTC. Yeah, there we go. USD. Yeah, we have that live on Metis. And so you want to bid and go ahead on the private chat. I just put a different one, 0.00001, like just 10% lower on there, because we're not having much competition. We're going to bid, this much ETH. And so we're going to say, all right, I want wrap BTC to be less than or greater than a certain price. So let me just check the market right now. It's
Okay.
it's 59,305 right now in the marketplace. So let's say it's going to be less than or equal to, and then we'll say 60,000.
60,000. All
Yeah.
right.
So now we're placing a bid saying, hey, I want to win the auction bid if wrap BTC is, sorry, not wrap BTC. We want to do BTC. Sorry.
Okay.
Yeah.
Okay. Yeah,
That
I
was
was
not
actually going to ask you, like, is
yeah.
there any reason we are using this asset? But anyway,
That one's because I'll show you in the marketplace which one's live. So we want to make sure that according to this, it's less than, and we know it is right now. We know it's 5305, but we want to make sure that we win this bid. So we're just kind of overdoing it. But when you're doing your calculations, you do your calculations to the exact amount that you need, right? So it's like, oh, if BTC hits 59,306, and that's what's showing up off chain, then we want to win. So if we place this bid, we're gonna win.
right.
Yeah.
So yeah, so that's what I'm wondering. Like the proper way to do this is with the exact number, not
Yes.
other thing.
Yeah, that's why either less than or equal to if we're going on to like a downtrend, or if we're greater
Uh-huh.
than or equal to if we're hitting an uptrend. Like, all right, if it hits greater than this minimum price, I want to update that price feed to run the liquidation.
Got it. So
Yeah.
should I press here, place
Yep.
bid?
Place the bid.
Let's go. My MetaMask has prompt. It happens on the
Yeah.
another screen that I'm not sharing. It says here estimated fee 0.11 cents, so pretty cheap, as you can imagine. And then I just have to press confirm,
Yep.
and let's see if this is already done.
Yep.
So I encourage everyone that is watching to go to this playground and try to take a look at it.
Yep.
It seems that it's done.
Yeah. So you'll see that the next tab is ready to go. Execute update.
Yes,
Here we're going
execute
to execute. Yeah.
update.
Right here. And so we're going to go ahead and switch to Metis, because now we're not doing it on the OEV network. We're going to go down to the bottom, switch to Metis, and then we're going to
Okay,
perform the update on Metis on here.
yes, this is very simple. It's only asking me to switch the network. Uh,
Execute the update.
and now let's execute the
Yeah.
update again. It will prompt my MetaMask,
So you'll
and
see
I
on the
have to, yep, I have
you'll
to
see on
pay
the
only
go
0.01 cents.
yeah, it's super cheap. You'll see on the bottom the collateral amount. This is how much is going to be staked from your OEV auction deposit. So if you don't report your update, you're going to lose that much ETH. You see on the very bottom collateral amount?
Got it.
Yeah.
Collateral amount of 0 point blah blah blah
Yeah.
has been locked up from your OEB action house because you can report your update. Okay,
Yeah.
very
And
interesting.
so you see like the data feed value after update, you see it's a little bit more 59,508. So we went up a little bit on the price. Instead of 305, and now it's 59,508. So it went up in value. So it updated to the latest. We basically pulled that data down to the Oracle.
This number are you talking
Mhm.
about?
That's the latest
Okay.
number that it is now. And so now, so you don't lose your collateral amount, we're going to go get on the last tab and report that update to the OEV network.
Okay, let's
Yeah.
do that. Report
And so we got
update.
to switch back to the OEV network.
All right. It's very well guided. Like it's only a few clicks. I'm now switching again from Metis to the OEB network. I guess that now that I switch, I just have to press again, report
Yep.
updates.
Report the
All
update.
right.
And then it's,
Collateral refund.
yeah. Therefore, you don't
Once
get taxed
again,
on it. Yeah. So you can keep
yeah.
using that same, as long as you pay out the bill, you can keep that bridge ETH. You can just keep bidding over and over. As long as you play well, that ETH never goes away, right? It's just used as a stake to make sure you pay. So like you don't have to keep adding more ETH to OEV network. As long as you do what you're asked to do, perform the update, you never get slashed.
All right. And the
Yeah.
status now has changed. Fulfillment confirmed.
That's
I
it.
have this hash. All right. Pretty simple. And the experience is pretty well guided. Congratulations to the people who did like this very simple but effective front end. I really
Yeah.
like it.
Yeah. So basically what we did is we theoretically bridged our value. I sent it over to you. So we skipped that part. We deposited into the auction house. We placed a bid saying, hey, I want to update this Oracle as long as it's within this criteria. We won the bid. We did the execution on Metis to update that price feed. and then we reported that we did that. We kept it honest,
Mm,
so then we keep our stake. And so now
mhm.
the next theoretical part would have been like, hey, let's run this liquidation, and then get that all before the reported update, right? We execute update means we update the price oracle and liquidation on that same call. What we're using here is a deployed multi-call, and we're going to go into an actual script of how that all works. So I'm going to go ahead and
Sure.
share my screen and
Let me
break
start
down
here.
piece by piece. Yeah. So let me just come back. But that's pretty much the OEV network. What you just did is oops, there we go, is the nice user friendly version of it. So I'm sharing my screen. And for those that want to fork and go, I'm going to paste this over in the private chat. This
Sure,
is
I
the
will share it
repo
here.
that we're going to be working on right now. This is the full
OEV
repo
structure.
here. Yeah,
Add in here to the comments.
there we go. So it's a hard hat framework. I like using hard. I know a lot of people like using Foundry, and Foundry is a really great tool that I use as well. With the scripts and certain things on deployments, I the team just prefers hard hat. So you
That's
can
because you
read
guys
really
are
well.
more old. I'm pretty sure about it.
Maybe, we're just given our age, but this is pretty much the layout. I want to cover a few things on here on the example EMV. It's going to take a mnemonic instead of a private key in case you want to use multiple wallets. The OEV network is pretty static. For that's Caldera chain. That's what we're using for the OEV network RPC. Your target network RPC is your L2 of choosing. So right now I've converted it to Andromeda Metis, and it's chain 1088. So that's pretty much when that drop down menu is how it's switching between RPCs. Our contracts have two contracts. It's the auction house, which looks like just a simple import. You're like, hey, where's the contract? Um, the concept here is we don't want you to learn how to fix a car. We want you to learn how to drive, right? And you
Right.
only need the artifacts in order to run it for the scripts. You don't really need to know how it works. The only thing that really matters is deposit, bid, and withdraw. But for those that want to learn about the auction house, oops, I just closed it out here. I can share that link in just a minute of like the details of the auction house, but it's just deposit, bid with Oracle, and withdraw. And that's it. You want to deposit your stake, you want to be able to bid with it, and you want to be withdraw your money out when you need to. And then
Got it.
the OEV multi-call. Okay. Multi-call has where the money is here, right? It's a thing that you don't have to change. For those that are familiar with multi-call, there is multi-call 3 that are already deployed on different chains, so you don't have to deploy your own. Do not use those, because when you do a liquidation, the multi-call is what's going to be doing the price update and the liquidation. So when you liquidate somebody, the money that you get, the reward, goes back to the multi-call smart contract, right? And if it's not your contract, anybody can front run your reward. So you paid for the update, you paid for the auction, you paid for the liquidation, and then the money gets transferred, and then somebody goes to your multi-call contract and say, hey, thanks for all the work, appreciate it, and then you get wrecked, right? So you want to deploy your
Right.
own multi-call contract. We have it with only owner, so we're using ownable. So then you are the only owner of the multi-call contract. For those that don't know much about multi-call contracts, I have a whole repo just dedicated to multi-call, a full
Oh,
tutorial just how to use multi-call. I even have a video walkthrough that explains everything on YouTube about like what it is, the breakdown, how to read things on multiple, function calls. So you can dive deep just in multi-call. I'm going to paste this repo in here as well. That way we don't have to spend too much time on it. Just know that you can bulk transactions in a single block call, or you can read multiple RPCs, right? Because when we are looking around for different positions, let me just grab this GIF here and see if that loads up, right? Oops, wrong one, wrong one.
I just shared on the chat
Yeah.
the
Oh,
GitHub
perfect.
with the multi
Yeah.
contract.
So multi-call contract can do one RPC call, so ready to take multiple transactions. So it can read data from multiple contracts on a single call, right? So like if anybody's done a front end, right, and they've done like a use effect loop, they get timed out because sometimes it gets looped and you get only so many calls per second, right? So
Mm,
when you do a multi-call contract, you send one RPC call, then that RPC call like communicates with multiple smart contracts, and it returns all the data from each smart contract. It only counts as one call. So when you're doing hundreds of different calls, right, you're saving RPC costs over time. And so being able to use a multi-call contract to read or deploy, you're now limiting it to one contract, right? So imagine you're reading all the positions on every borrow lending DApp on Metis. You'll be there for days with RPC calls running per each transaction. So you want to use one multi-call contract to read as many as you can, and then get that data back and then host it on your local database, right? Um, just an example for that, if we were doing it singular, we're searching, we're looking at all different positions, right? Like we want to be able to just throw it on multi-call contract and read all those contracts at the same time. This is kind of like a visual explainer. This is all in the video, but sometimes, having a visual just kind of helps you understand a little bit better. And then so
Yeah.
what we're going to do is, for the point of us, is we have the searcher, we're going to do multi-call contract. We're going to combine our transactions of the price feed and perform the liquidation, and then it's going to go do its thing. That's what's happening in the multi-call script. Again, you don't have to know too much about it. Just know that I want you to drive, right? If you want to deep dive, you have that GitHub repo. You can look at all the details, but it's here for you to break down. Basically takes an address, the smart contract. It takes the data in bytes. So basically, function calls are converted to bytes. And if we need to send any values, like how we have to pay the auction bid, we can then send values, and it has an only owner to make sure that when we receive any value, we own that contract, right? And it just loops through the information on there, and we'll break it down. But we're like almost out of the hour, and I know we're going to go over, but just wanted to kind of like help explain like what multi-call does for our contract. So breaking
Yes.
down this
Someone
repo.
here, sorry to interrupt there, but they say that the latest link seems to be broken. And if we can please check that out. I am going to be opening this on a new tab here.
Okay.
And yeah, it's actually gives me 404. So I think we should, is the one for the multiple calls. Uh,
Multi-contract. Okay, let me.
yes, the multi-call contract.
Okay, I will make sure that goes to public in a second, just in case. I'll make sure to turn that live before that. Just put a reminder on there. But I will get
Yes.
that multi-call contract, and I'll also repost it on my Twitter just in case on there.
Yes,
But I'll
yes.
make sure
And
that's
by
good.
the way, guys, I know that some of you are just tuning in. Thank you for joining this amazing workshop that we are having on OEB. And we are going to be creating much more material about it because this is truly amazing. So we will have a review about this with all of the links that we have been sharing so far. But if you have any other questions, please feel free to add them.
Yeah, I'm doing it while you were checking. I'm just making sure that that is public. So I'm making sure that's public. Figure we take a quick break on that. Let me just pass that in there. Apologies for the delay. And it should be public now, just in case.
All right, let me update here just to make sure. Yeah, it is public now. You guys can
Okay.
see multi-call tutorial. Amazing. Thank you very much.
Okay. MPX hard hat clean. I'm just going to clean up this repo because I did a quick check. And so hard hat config. So for those that are familiar with hard hat, you're used to seeing kind of like imports, different chains, different .envs. What we have here is we made it really, really simple. Basically, for our networks, we have something called API3 chains. Basically, it's every chain we've deployed on, we already have contract addresses. Instead of juggling contract addresses, we have a repo that full has all the contractors available to you. So in the repos here, in the example, you'll see that we have all these smart contract, pretty much deterministic, with chain IDs on there, right? So chain, mainnet and every other chain ID that exists out there, all the way through the OEV network. Instead of typing in a whole bunch of contract addresses, we have this import where you can just use it and refer it to. So we've set that up to basically, have API3 chains. So instead of like you're seeing like all these different chains with private keys or like mnemonics, it's all put in a nice package for you for API3. So if any of those contracts ever change, you don't have to keep redoing your hard hat network interface. It's just kind of ready to go. Just wanted to like make sure that we cover that, because when someone tries to follow the usual hard hat package, they're like, hey, where are the networks? How does it work? Right. So
Yes,
want to make
you
sure
need
that's
to
good.
add them.
And then also in the package.json, we have these scripts. So it's pretty straightforward. You can use yarn build, yarn deploy multi-call for your multi-call contract, and then deposit our collateral, and then the submit bid and update. So we have these ready to go. You'll see these scripts are right here. That way you could just use yarn and the name of the file, and they're ready to go. So really easy for anybody to use, to follow along, and just play with it, right? The only thing you need is to make sure that you have a little bit of gas on the L2 that you wanted to choose, which was, again, your example target network. Right here, we're using Metis. You need a little bit of a Metis token, and then some ETH on the OEV network to basically do bids and whatnot. So first thing we're going to do is we're going to go ahead and cover the multi-call, deploy multi-call script, right? And so we have our contract for multi-call here, and we are doing the API3 contracts. And basically we're creating a, let me go ahead and minimize this. We are creating the object, right? So we're doing the network provider, which is our Metis RPC. And then we have our private key from phrase. So we're using a mnemonic on this, and we're building the object in order to just basically deploy it, any standard deployment on there. And so we're going to console log deployed it. The only thing we're doing different is we are keeping a copy of our deployments on here so we can refer to it later. So sometimes when you do your console log, you have to like copy and paste your address and then update it to your next script. Here, we're just keeping it under scripts for deployments, and then we're going to refer to it a little bit later. So I'm going to go ahead and just run that. So I'm going to go yarn deploy multi-call, and it's going to deploy our multi-call on Metis L2 because we've already set it in our .env. So it's going to
Okay.
compile, and then we should get a little thing here that says deploy multi-call, and there we go. We have our deployment, and our multi-call contract is right here. And if we look at our deployments JSON file, it's here. It's stored on our local file, so we can reference this at any time, right? And so now we have our multi-call deployed on Metis. It's live. This is happening on mainnet. It's not happening on testnet because the OEV network's only on mainnet. So it's really cheap. It costs like 0.0001 Metis. It's like super cheap to run transactions on there. Now that we have our multi-call ready to go on the layer 2, remembering that big chart, we want to make sure to deposit our collateral, right? So we
Right.
want to make sure that we're placing our bid. Like just to bring back this OEV network, right? We've basically have our ETH there. We want to deposit now on that next step. So we basically run the same thing. We have to create our object on the OEV network. So we're using that OEV network RPC, same private key. We're getting the artifacts from the auction house, is why we have that contract here for the auction house. We just need those artifacts. And we're going to deployment addresses. Remember, chain 4913, that is the OEV network. So if the address of that contract ever changes on the contracts, it will automatically update, but it's going to be used 4913. And we're just going to deposit 0.0001 ETH, right? Something really small because we don't have a lot of competition. And we're only going to call one function. We're just going to deposit on the auction house, right? We want to deposit some ETH to make sure that we have a little skin in the game. So that's pretty much all we're going to do. So I'm going to go in yarn, deposit collateral. Bring that up. As soon as it goes. And there we go. We've deposited 0.00001 ETH into the OEV auction house. And this is our transaction house. So now we can create bids and do whatever we need to do on there. So far,
All
so good.
right. So
Yeah.
far, so good. I
Okay.
think the experience of doing this, like the front end, and
Yeah.
then going and checking out these contracts is
Yeah.
really, really something that I would encourage any dev that is getting started to do it. I mean, I'm gonna check it out as well. It's very, helpful to do these two things, right?
Yeah.
Separately.
So now this next script, which is called submit bid and update, is basically these next few steps, right? We're going to place the bid, we're going to execute the update, and then we're going to report the update. This is all happening on one script because if we take too long, we lose our bid, we lose our slash. But we're going to break this down. This is kind of like the meat and potatoes of the entire thing. So let me just move this over a little bit. Let me just make this smaller. We're going to break it all piece by piece, right? So we're bringing in imports for ethers, right? So we are bringing them each item one by one. A lot of people do ethers star, so bring in the entire ethers library and then they hit ethers.wallet or ethers.contract. The team just chose to do each one individually, so you can see it one by one, but pretty standard like contract, RPC provider, Ketchak, Solidity, ABI coders. So these are all tools built into the ethers library. Pretty straightforward. We're using our contract addresses from the API3 contracts, so we know how to refer to that. We're hitting our deployments.json, which is basically our multi-call address, just right here, just to make sure as a reminder. our multi-call address that we're going to refer to. So we're not messing around with contract addresses, and then .env for my hidden EMB files for RPCs and whatnot. So few things that are required on here is a bid topic. So currently the bid topic before used to be a combination of chain and the price view we wanted to update. But now our current auctioneer only requires a static return of bytes. So this is just a static call that will return for the bid topic. So the current version of the auctioneer only requires this return of bytes in order to work. So we're just hard coding it. You don't really have to do anything with it, but I feel like I should explain it because it's not like some random number, right? But this is what the current auction house requires for it to know. It's like, hey, this is for the current auction house. This is the bid topic that we're going to do for all layer 2. So it doesn't really matter which layer 2 you use. The bid topic is the same in this current auction house.
Got it.
Yep. And so with multi-call, everything is in bytes, right? It's like, the data that we had, if you remember correctly, like when you deploy something, it has to be with bytes. So we need to convert all our bid details in bytes. So the bid details is the proxy address, which is the price feed address, right? Like the proxy address we'd use for the reading the price contract feed. The price feed in your contract. It is the proxy address. We have to put our conditions. Remember, our condition is a greater than or less than a certain price. The condition value is like, well, what's the price that we want to do? Like we did 60,000 last time. And then who is doing the update address, right? Who is our multi-call contract is going to do the update. So this function, all it does is encode all this. So you'll see that it has the API encoder from Ether's library, and it's going to check our bid conditions. And it's just basically going to loop through all the conditions on there to make sure that we have our proxy address, our condition, if it's greater than or less than, what is it going to be greater than what price or less than what price, and then who's doing the update, which is going to be our multi-call contract. And then it's going to random like just put a little randomization into our bid, because if two people bid at the same time for the same exact thing, how do we separate it a little bit? We're just adding a little bit of randomization on that bid, so it sets it apart. Make sense?
I mean, I have to, yeah,
Yeah.
it makes sense, but I'm gonna have to go through it on
Yeah.
my own. This is the kind of things that you really need to sit down
Yeah.
and, do it on
In a
your own.
sense, all we're doing is basically turning all this information into bytes. The proxy address,
Right.
like basically all our select network and select data feed, all that is basically being encoded right here into a simple thing
Ex-
happening behind the scenes. So you don't really have to modify this. It's just a function that we're going to call to convert our bids.
Okay. All
Yeah.
good.
Okay.
So maybe this is a good point in which we can highlight what are in general the requirements that we are going to be having in order to run this full repository like on my own,
Okay.
even if I don't have access to this video, just so that developers are aware of it.
Yeah, so it's that GitHub repo. You just basically need to fork it, yarn install for all the updates, and then make sure you have a little bit of gas on the layer 2 that you choose. That would be on the .env file, and then a little bit of ETH on the OEV network. So if you're doing on Metis, you can use this exact RPC. I just grabbed it from the docs, and then this is already pre-built in for you, and then adding in your mnemonic. That's all you
All
need to
right.
do. Yeah.
Pretty straightforward. Love it.
Yeah.
Thanks.
And so here we want to do a place bid. So now we're actually going to place our bid with all the details. So we're going to have our proxy address. And so basically this is which price feed update do we want to update, right? So I'm going to go ahead and just go over to market.api3.org, right? And I'm going to go to Metis on mainnet. And here's our Metis. And we're going to look at our live price feed. And we know that BTC USD is the one that's updated. So we're going to click on that. And we see that this has your latest update that you updated it to 59,690, right? And so I want to update this price feed, right? And if we remember from the first workshop, we got that contract address from the proxy address. This is the address we want to update, right? This is the BTC USD price
Yeah.
feed proxy on Metis right here. So I'm going to go ahead and move that to the side, and I'm going to paste this down right here. This is the price feed that we want to update. Boom. I already did it before, so it's the same address, right? We're going to check the chain ID. So the default Metis mainnet is 1088, right? And the bid amount is 10% less of my deposit. So it's like extra zero. So 0.000.001, right? That's how much I want to bid. If we were having much more competition and it was much more exact, this bid will go much higher, maybe 1 ETH, 2 ETH, depending on what the value is for the liquidation. And my bid condition, is it going to be greater than or less than, right? So I'm going to say less than, and currently the price is 59.60. So I'm going to say 60,000 is what it's going to be less than, just to make sure that I win this bid, right?
Hmm.
And so now here it should look like normal. We're building our object, right? We're getting our RPC, we're getting our private key, we're getting our artifacts, and we're using chain 4913 for the OV auction house, the same way we did it for the deposit. And so now we're going to get our bid topic, which is basically this one constant file of this bytecode, right? And then we're going to do our bid details. So remember, we're calling this script right here, this function, in order to do what we just did. We said, oh, I wanted to encrypt our proxy address. We wanted to encrypt our bid condition, how much we're willing to bid, and less than, greater than. And we want to make sure that our multi-call is the one that's going to be doing the update, right? So we're just calling that function to encode all this details, right, of that
Got
we
it.
put in there. Got it? So I'm going to minimize that. And so now we're going to place our bid, right? We're going to go right here. We've filled out this form already, and now we're going to place our bid according to this frame. And so we're placing the bid on the auction house. So we're placing a bid with expiration, which is going to be the bid topic, right? And it's going to have our chain ID, the amount that we wanted to bid, has all the bid details already encoded. And then we have our collateral basis points. It's basically how much collateral are we willing to risk to do this auction update. Remember when you saw it on the front end, it tells you how much collateral based on how much you deposit. Remember that 0.0000, like 0.9 something. That's how much you'll
Yeah.
get slashed if you don't. And then the protocol fee is how much you got to pay. That is set to the max too. You got to pay out the fees on there. So you have to pay the 90% to the DApp, 10% back to the OEV network. And then how long will this expire, right? So we have this date. Basically, this bid will expire in 12 hours. You can do an expiration time of whatever you need, a day or so. I can't imagine anybody would have a longer bid than that for the day, because volatility is when these auctions happen. So, an hour, 2 hours, 12 hours. I just do 12 just for demos. But
Okay.
these are pretty quick. These are pretty quick. And so it's going to basically let us know that we've placed our bid. Here's the transaction house, and then a console log that said that the bid has been placed, right? And so now what we're doing is we are computing our bid ID. In order to hear our details, we want to know if we won or not, right? So in the back end, we are basically doing the catch-X and encoding the address that we have, which is our OEV network wallet address, our multi-call, the bid topic, which is this same topic again, that was that static bytes value, and then basically encoding of our bid details again. So that way, in the bid ID in the auction house, we know which one of our bid. Do we know if we won? Do we know if we lost? We're going to be listening in to our specific bid ID that we just placed, right? And so we're going to set up a listener to say, all right, did we win or not? Basically. So it's going to
Right.
be a promise of just waiting for the bid to be awarded. It's listening to the auction house and to see who won the bid. It's going to let us know if we won or if we lost, right? And so we basically, this does some magic with some filters to let us know if we won or not. If we win, we have this awarded transaction, right? We won. Here's our signature with our multi-call contract address that's going to allow us to update the price feed on Metis, which for our case is BTC USD on Metis, right? And so once we have this reward, we're going to go ahead and update the transaction. So we're going to perform the OEV update on the actual price feed and update to the latest price on there. And then we're going to report that transaction back to the OEV network saying, hey, we've updated our transaction. This is our bid topic. These are the details. And this is our bid ID. OEV network says, okay, good. You get to keep your stake, right? And so this perform OEV update function call basically has all the details of like where we're going to go. Let me update this update mantle mainnet right here. So we're going to go ahead and 1088 and make sure that we have the right chain ID, and then make sure that we have the right bid amount, and then basically builds the objects and then says, hey, this is the rewarded amount. We should be good to go. Basically, that's all we're letting everybody know. Hey, this has been updated. And then with the update transaction, basically saying, hey, we've updated it. We want to make sure that everything is good, but we want to do this on multi-call, right? So we're going to update our transaction with the multi-call. And here's where the magic is all about multi-call. You see these array points? This is where we bulk all our transactions. We do transaction 1, transaction 2, transaction 3, right? So in this array of transactions, we have our contract addresses for the API3 server for our chain ID. So we're doing this on Metis, right? And so we want to make sure that we are pay it back. We are going to update it with our awarded transaction, which is that return transaction that we got if we won the bid. And then we want to pay our value amount of how much we got to pay. And then we're going to send that value. If we were going to do a liquidation, we would put a comma, right? And then in here, do our contract address of, like, let's say the AVE or whatever contract liquidation, right? So we put the contract address here, and then we would do our liquidation transaction here in bytes. So we put another comma and then another array of transactions in bytes, and then whatever value we had to pay back, and then any value that we needed to transfer, right? So maybe we'd have to bulk up approve and send transfer, so we can bulk up a multiple amount of transactions in this multi-call to send in one block. So this is where the magic of the multi-call happens. And then
Got it.
once we've done all that update, then we're just going to say, hey, we're reporting back our fulfillment, which again is this report fulfillment transaction that has all the transaction details that we build up, and basically saying, hey, the Oracle update has been performed. Don't slash me. We're good to go. Oops, sorry, right here. Report fulfillment. We're good to go. And that's
Got it.
pretty much it right here. So depending on the block explorer, sometimes the report fulfillment can go. Sometimes on Block Scout, it's like 50-50. But that's pretty much the overall layout, right? We place the bid. Just to recap, we place the bid, we execute the update, we got the reward, we execute it and report back to it, right? When we get into details on liquidations is where the multi-call stands out. So that's why I say definitely learn multi-call, learn, like, how it works, because this is where we'll start adding additional stuff here of like
Got it.
adding extra transactions and everything. So this is where a little bit of the magic happens. So line 127 or 126 to like 137 is where all the multiple transactions happen on there. So let's go ahead and make it happen. Let's bring this back out, and hopefully this makes sense. I'm checking the comments here, but let's go ahead and go yarn submit bid update, right? So we're going to submit our bid. We're going to go through the terminal. We're going to see if it hangs. Okay. And let me just go here, check this really quick. And totally forgot about this one super cool tool. I know we're like over time, but this is pretty important. I'm going to grab this. It's called Centurion. This is a tool that we use to check prices here of like what's the actual price value, right? Because we've been updating price feeds, but it really hasn't been telling us exactly what price feed is happening, right? So let me
Can
go
you share
here.
the link with us over the
Yes,
private chat so I can share it with the rest?
definitely. I'm going to take us all the way to Metis, and then I'll share that exact link here. Here we go. App chain 79. Okay, here we go. Put this in the private chat. There we go. And so you see that we have 2 live feeds right now happening on Metis. I was going to say lettuce at Metis. So we have BTC USD, which is live right here. And we're looking at the status here. So I'm going to go ahead and click on BTC USD. And you see every minute on the minute, it is checking the price feed, right? Right. And we're also comparing it with other oracles. What are other oracles using as price feeds? Are we compliant with, are we within range of these oracles? Our sign data on chain shows what value. So let me go over to the market here, refresh this, and see what's happening. So 5960 right here, 5960 is what the API3 server is reporting, right? And so that's reflective on the market. What is other people, like, we're on an uptrend, so it's a little bit higher. So it would make sense to do the OEV network, right? Our signed OEV network has 59,746. So if I do a price update, it should reflect to that update. We are within range of other oracles. So like if something is very wonky, the team gets notifications saying, hey, you're submitting oracles that are very different from other oracles out there. Maybe something's not safe, maybe something's wrong, inspect this, right? So this is a way a lot of people use to say, hey, if the real value is 59,746, I would like to update my oracle to this latest value, so then I can run the liquidation. So this is how you can really check an exact price on there. So that's one tool that we use in order to make sure that when we're bidding this update, we want to make sure that we're updating correctly to the right value. This was also done on the front end. Like, remember when you hit the execute update, it lets you know the current price. It's pulling that current price from these values here.
From these values.
Yeah.
All right.
So let me move all this to the side and actually run the update. We're going to go through all of it right here. And it's going to take us through that quick script of everything that's happening, right? So we want to place our bid. We've already deposited on the previous script. So we're just going to go ahead and run it. So the bid has been placed. We're listening to see if we won the bid, and the bid is awarded because we did 60,000, we won. And so now that we have the awarded bid, we want to go ahead and update that transaction. So the Oracle update has been performed and it's waiting for the confirmation of fulfillment. And sometimes on Blockscott it's 50-50. Oh, but it worked. It confirmed the fulfillment. And if I bring this over, it's been updated to 59,714, the latest price update on there. So remember, it was 59,600 and something before. Now the
Hmm.
price update is 617. I can run my liquidation with the multi-call, make it all happen. I've performed the fulfillment update. We're ready to rock there. I don't get slashed. Everything's happened all instantly, right? On a script.
Yeah,
So yeah,
amazing.
pretty
This is
straightforward on there.
yeah. Once you get to understand like the code, what it's doing, where the
Yeah.
magic happens, it's pretty
Yep.
straightforward.
Yep. Yeah. So like that's why like each one is kind of like basically commented a bit. This video will now be reference, right, of the code breakdown. You can get, it now it comes down to like, okay, well, how do I run a liquidation? How do I see how health factors work? How do I pay back the loans? Those things, that's going to happen in workshop 3, right? Right now
Yeah.
we're learning how to update this Oracle. Now it makes sense. Now that 0.001, it's not very much, right? But that is what goes back to, the borrow lending DApp as I go. So like the more competition that there is, the more money that will be bid, the more money they get back on there. So like by
Hmm.
using API3 oracles, you're getting some value back when you get liquidated. With other oracles, as of now, as far as I know, to a certain extent, you don't really get much. You don't get anything. So
Yeah.
OEV is like it's a fairly new subject, right? People are still understanding, what is OEV? Extractable doesn't sound very good. But we realize where the value is the Oracle has to update first in order for any things to happen, right? In order for any liquidation to happen, the Oracle must do the transaction on chain first in order for any liquidation to happen. So we're just auctioning off the ability to do that to the most current price by allowing the push Oracle to be a pull Oracle and pull that data down to on chain to perform the liquidation.
Yeah, no, this is like, the more I think about it, I think this is such an improvement that I think is going to be inevitable that all people start looking into this at some point. I think it's going to take a little bit of time until
Yep.
people start to grasping like the idea because it's a little bit technical. I
Yep.
get it.
Yeah.
But very interesting stuff. So uh, yeah, I don't know if you have like any call to action or final words on my
No.
end.
Uh,
I just yes, please go ahead.
Oh, I was just gonna say, like, reach out if you're playing with it and you have any questions, reach out to me, reach out to the team, reach out to Discord. I mean, the playground is something that we can, experiment with, but what can happen, and this is kind of a dream, but talking to the lead, my lead dev on here of like what could be is we've been looking at like maybe having dashboards, right? Having dashboards that can work and say, hey, here's all the borrow lending positions on Metis and here are the liquidational prices. You, as a regular user, you're not a searcher. As a regular user, would you like to bid 5 ETH to run that liquidation? And then everything gets run for you on the background, right? Like the way you've placed the bid, how much do you want to bid, and this. But now you know the exact price because it's been calculated for you. And so then it can do like a flash loan for you and do everything for you. So like if you win that bid, it does everything for you in the background. So now
Yes, that
average
would be amazing.
users can help keep the ecosystem healthy and win too, right? So like this is just the beginning, right? We're running on scripts, but you see that we have a front end working. It's pretty easy to use. We're on different chains. We're bringing MEV and kind of like value back to layer twos, right? When it didn't really exist. And, you'd had to like figure out different ways. We're trying to make it easier. That's why I call it MEV on training wheels to be able to do certain things like this. So, like sparking ideas or any ideas that people may have to use on the OEV networks. We're going to start having hackathons, right? Like at eTokyo, we're going to have one. We'd love to see how people take advantage of this situation, right? That's just one idea for dashboards. What else can we do, right? What else can we do with this newfound value that goes back to the dApps? So like we're gonna see where this goes. It's still fairly new. I think it's been a month, and people are slowly picking it up. We're doing more workshops, so I'm very curious to see and love to hear feedback from people of like what they think of it, what ideas may come out of it, and see what comes of OEV.
Amazing. That's for
Yeah,
sure. So
yeah,
for the people that are watching this, you are early. Like this is the
yeah.
definition of being early.
Yes, yeah.
When you get these kind of opportunities, knowledge is power, knowledge is freedom. So I would encourage you to take a deep look into this. And if you have any questions, please feel free to reach out to me on social media and to reach out to Billy Jitsu. There's also like the Discord of API3 and then the Discord of Metis. You can reach out also on Telegram. There are multiple ways to reach out. It's fairly simple. And yeah, I would just like to ask the people that are watching this to please subscribe to our channel. It really helps us to kind of keep pushing like educational content that is beneficial for everyone. And we're very, very grateful for your work here, Billy. And I think that we are going to be having more fun in the future with future workshops.
Yep. Yeah. Again, stay tuned for workshop number 3. I know a lot of people will be excited about that. Deploying Aave through a CLI tool. It basically covers workshop 1 with the adapter contracts, learning how borrow lending works, getting health positions. I mean, we covered like we're over the hour here. I knew it was going to take a little bit low over, but yeah, like it's going to be a 2-part workshop. So definitely check back to the Metis YouTube channel, and we'll be breaking it down piece by piece. Like if you didn't know DeFi, you're going to learn it. So it's going to be
Yeah,
exciting. Yeah.
yeah, it's gonna be exciting. I can assure you that. I've been having so much fun. So thank you so much for joining once again. And one final call to action for the people that are watching. In about 45 more minutes, we have a Telegram call on with the Metis developers. We are going to be talking about the upgrades of our network. So I invite you to join as well. So yeah, that would be all. Thank you once again, Billy, and catch you on the next one.
Yep. See you guys.